There we go. I didn't bring speakers, so it's going to be, if someone's talking online, we're not going to hear them. That's okay. That's what I get for not being here.
Sounds good. So one day in a Google engineering lab, there was this fateful day where someone released a paper called "Attention is All You Need." And this is a very famous paper that's been extremely quoted recently. And the reason why it's pretty relevant is because it is the paper that introduced the data structure known as a transformer. They built upon a couple other things. But essentially, it's a way that you can make you can make this data structure called a transformer. So how many of you guys have ever heard of a thing called a neural network?
Yes. Yeah.
Perfect. So in a normal neural network, just for review, there you have a bunch of different weights, and all that weights are is like, imagine a bunch of different float variables that are in an array, and then you call these lists, this array of, let's try this simple example. Yeah, so in an array of floats, you call those one layer. That's your first layer of neurons. And let's say you have two of these layers of neurons. From one layer to another layer, you also have links between every single one of the neurons, are linked to every single one of the other neurons in the following layer. They're all added together and multiplied together. And the idea is that if you put enough of these layers side by side each other, you can do this fancy algorithm called backpropagation to set the weights and update the weights as it goes to the neural net. So essentially, like a popular example is there exists this data set in order to view what number a particular, I want to say 256 by 256 pixel image is. So let's see if I can find that real quick. So image data set used for numbers popular in neural networks. Yeah, this guy right here. So here's a bunch of like 256 by 256 images, and these values all, I think, range between 0 and 1. 1 being like it's black and 0 being it's white, or vice versa. I don't remember which way it was. But you put that on your first layer, and then what you do is you do all the matrix math multiplication throughout all the different layers, and at the very end, you basically give it 10 choices. It can either be a 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. Those are the 10 choices. So then you show it the image. It does the calculations. At first, you initialize it. It's just random weights. And so the output is essentially random. And then you go, no, silly, that was a 5 in this first case right here. So then you do the backpropagation algorithm, and then it updates. And then next time to show it the same exact image, there's more of a likelihood to show that the outputs would be a 5. So these neural nets are deployed in many different ways, and anything in certain definitions that uses the neural network can be considered an AI, where there's a lot of talks of what is and what isn't AI. Like some people, by certain definitions, will say, oh, anything that has an if statement and that has a variable that you can set or not set technically is being a decision being made by a computer. So as a result, it is artificial intelligence. But traditionally, it's like any algorithm or set of algorithms that uses neural networks in some way or another. So in this Attention is All You Need paper, they organized or orchestrated several of these neural network clusters together, where in addition, instead of just having these transformer layers set out one after another, they introduced this architecture right here, which I don't know if you can really quite see that, but essentially you have your input. A transformer is specially optimized for text autocomplete, essentially. So if I said I went to the, someone give me where they could go here.
Bank.
Store, bank, yeah. See, so that's essentially what this is meant to do. So in order to get text input to output, what they said is step 1 is you take your text and you convert that into what are called embeddings, essentially. So you, in order to, all that an embedding is basically an array of numbers. And in order to take text and convert it into the embeddings, you can use, in order to turn it into embeddings, you need to first tokenize them in order to turn it into numbers. So on OpenAI's website, they have this thing called a tokenizer, which is really neat. So a tokenizer is you take any list of text. I'm just going to take some random text here because I don't have any text. I'm going to put it in here. So here's some text. And then it turns it into tokens. So you can see this text I just implemented right here is 36 tokens or 179 characters. And here you can see how it highlights it. In general, it works out to, on average, one token is about 4 characters, but it doesn't have to be 4 characters. You can see here in found, it is 5 or 6 characters, and here in it's 3 characters. But sometimes if you do an example in here, so that's this guy. In certain scenarios, for example, tokenized, you'll see that based on their algorithm, it can sometimes split one word into multiple tokens.
So if you want to type in supercalifragilisticexpialidocious.
Oh, you make it into a whole bunch.
What's it gonna do?
Yeah,
You can do about 5.
super, I don't know, it's called like califragilisticexpialidocious. Yeah.
Wow. Yeah, 14. That's pretty good.
Yep. So
AI, it's supposed to know.
Well, that's right.
yep. Yeah.
Well,
This first embedding its algorithm is actually just essentially a lookup table between a sequence of characters, as far as I know, or an algorithm that basically can act as a lookup table. It just is a straight conversion from text to numbers. Because like you can see how they're highlighted here, but let's look at their token IDs. So every single one of those highlighted token pieces that we saw is actually just a number. And then with these numbers, it's now in quote unquote a form that computers can understand much better than actual text. So then we can take these tokens and turn it into an embedding to put it inside of this artificial intelligence. Technically, there's one more step from tokens to embeddings, but for now, let's consider it to be done. So you put in the embedding, they have positional encodings in order to put things, and they have what's called multi-head attention. So where now, instead of it just being a single neural network, it can have several neural networks side by side, and also you'll have a second layer of neural nets that watch the input to see what parts of the input are probably important about what comes next. So given a, like I went to the store, and when depending on what you're trying to ask, and then you tell a whole story, and then at the very end of it, you go, where was I? The attention has to figure out what things in a sentence tend to be important to look at. So as a result here, it will probably look at more things that are related to like nouns and essentially nouns here of where I would be, and then filter it that way. So there's a bunch of mumbo jumbo here that I also don't actually understand, to be honest, for functionally using it, but there are quite a few good YouTube videos online that make you, when you watch them, it makes you feel like you understand. So I would recommend those. So essentially, after you perform this multi-headed attention, and then, like I said, there's like 2 of these networks side by side. So one of them shows it from just the input going to the output, and then between each of the layers, it's a combination now of not just the first neural network of what happens to the embeddings, but also the secondary attention network that tells you what to actually look at in the input at every single layer throughout the. And then from that, you get an output set of embeddings, which is the output of, for example, like ChatGPT that we see today. One of the things that is the most important about this particular type of data structure compared to what was done previously to it is that, as far as I know, it is parallelizable. It's on a GPU, which means that
can run parallel tasks.
Yeah. So because of that, when you have a neural network, there tends to be 2 different methodologies that you use in a neural network. One is the training process, and the other is the deployment process or implementation. So in the training, it uses a lot more resources because every single time you do one feed forward thing, you do back propagation throughout the entire network. And that's very CPU intensive, or sorry, CPU or GPU or computation intensive, I'll say. And now, because this can be done in the GPU, you can put these large amounts of text that you train on in batches across many GPUs, so it can really go through this data and crunch some numbers, which is great. In terms of these neural networks that we're dealing with in today's world, if you look at GPT-3 as a whole, if I recall, it has around 300 billion parameters. So, and a parameter is like one float, for example. So we're talking about crazy systems. So like if you were to download GPT-3 and put it onto your computer, to my knowledge, it would be roughly like 300 gigabytes. So one thing that's kind of interesting, I don't know if you guys have played with ChatGPT or not, but it can answer a very wide range of questions, pretty much anything that you want it to. And it's kind of crazy to think that almost all of human knowledge can be compressed into 300 gigabytes. It's crazy.
And that was frozen, what, 2020 or 21?
Correct.
Yeah.
2021 is when the training finished for,
Yeah.
yeah. And it trained for quite a few months, which is very fun. Large language models as a whole all tend to use transformers in one way or another, and they'll have their own optimizations and modifications on how they use this. Like one example of modification is instead of all the embeddings that it references are only in the weights and only uses what comes in the weights and only uses what the input embedding is they have some of these systems now to where when it goes through, it figures out what else it should ask, like for example, the internet about. And then as it goes through, it'll be able to Google and get even more information from the internet, for example, and incorporate that back into its algorithm in order to keep going. So sometimes people do that internal to this algorithm, and sometimes people take this, put it in a box, and then with some logic, they decide what they want to do with it.
Another wrapper.
Yeah, put it in the wrapper. So there's some fun stuff. Let's see what else is on our to-do list here, shall we? So yeah, so those are large language models and what the definition and overview of them is. So then there's a bunch of different large language models, including GPT-3 and GPT-4. So for this, I think what is really interesting is if you look at GPT-4, this is so as an overview, so GPT, quote unquote, stands for Generative Pre-trained Transformer. And that what we just looked at, that was in that paper called Attention's All You Need. It's a transformer architecture. So OpenAI, quote unquote, came up with this idea that instead of using transformers and train them for particular niche cases, what if we just trained it on all of text, basically, and then had it very generalized and pre-trained for anyone else? So you can just instantly plop it in wherever you want. So that's what G in generative, meaning it makes stuff, pre-trained, meaning like it's preloaded with a bunch of machine learning and then transformed to data structure it uses. So then they made GPT-1 internally, then they released it, and they're like, wow, this technology is kind of crazy, but we have ideas of how to optimize this. And then they internally made GPT-2, and I don't know if you guys remember some of what happened then. They were like, hey, this seems like it can be pretty dangerous. We're a little bit worried about even releasing GPT-2 at all to the public. And they tried to be pretty vocal about it and talk about the problems with having it, the fact that it can generate fake news. And at that point, you can ask it stuff, and it doesn't necessarily sound coherent, or it won't necessarily make sense, but it does sound like a human BSing, essentially, at that point in time. And then eventually what they did is they broke it out into different parameter model sizes. So you know how I said before that GPT-3 is 300 billion parameters, I think? If I look up GPT-2, and then I look up GitHub, it turns out that slowly over time, they broke the model, they trained it at different parameter sizes. So they released the very smallest model that was the most limited, and then a little bit later, they released a larger model, and a little bit later, they released an even larger model. And now, today, you can download all of GPT-2 and run it locally on your computer at home.
Really?
Yeah, so this is the OpenAI/GPT-2 GitHub that you can download and run it on a GPU. It does have some fairly beefy memory requirements, but it's totally possible to run, I think, even on this MacBook CPU, for example. It would be quite slow if I did so, but it's possible. So yeah, then in order to do this, you also need to download the weights. It's been a hot minute since I've looked at this though. So there's a thing called downloadmodel.py, and they have some stuff to tell you about. But basically, you specify one of the models here. So for example, 128M, which is 128 megabytes for their 128 megabyte model. And then it'll download it for you, essentially. So you just clone this, and then you can run Python space download model.py space 124M, and then it'll download the 124M model. So you can see that that's a small model. There's also a medium model, which is 375M megabytes. And I forget what their large model is too. They had two more, I think, maybe up to one after M. B. Yeah, get
Gig,
yeah.
G, gig.
Yeah. I think these are parameters though. So instead of
Oh.
million, it might be billion. So it might be one B. I don't know. Anyways, yeah.
Change.
So they released GPT-2 fully, and then pretty much at the same time they released GPT-3. And they're like, guys, this is getting really crazy. You know, we said before, the same thing again, but even more crazy because now it's starting to actually kind of make sense depending on what you do. So one thing is with how GPT-3 was made, they had a giant corpus of text that they basically found from scraping the internet, including but not limited to the pile, which is just the name of a really large pre-made data set of a bunch of different sources compiled by someone online. So you can download the pile, and it's some crazy large size. It's a bunch of text on Reddit. I'm sure they probably took like YouTube transcripts, put it in there, take all of Wikipedia, put it in there, a bunch of different sources, and they put it in there. Now, one thing, I don't know if you guys have ever been on this website called Reddit, but in addition to having facts on there, there's also lots of fiction on there. You know, there's a bunch of stories and wild, and like there's talks about dragons and whatnot from fantasy stuff, and the large language model just reads this giant corpus of information and there's no way of knowing fact from fiction, essentially. So sometimes when you would ask GPT-3 what to do, like you would have to what they call a prompts engineer in some way to try to get it to do exactly what you wanted to and give it enough context that way hopefully it reached a niche enough category inside of its model structure to like give you a good accurate response. Otherwise it would give you garbly good. You couldn't say, for example, give me the 12 most popular US states or something. It wouldn't respond to that. Instead, you had to say it only did auto completion of text. So you would have to say the 12 most popular states are, and then like it would complete it. It was writing a sentence. So GPT-3 was crazy, and then this thing called ChatGPT came around, and ChatGPT is also sometimes called internally GPT 3.5. And what they did is they found a way to try to mold GPT-3 to conform to humans more. And they did this using a process called RLHF, which stands for Reinforcement Learning with Human Feedback. So reinforcement learning with human feedback is basically you use GPT-3 to produce something, and then a human will go through and will give basically a bunch of feedback of like, did the output of this contain the answer to the input? Yes or no? Was it too long? Did it include all the key points? Did it include other content that shouldn't have been inside of it, et cetera, et cetera? All these things that a human has to go through and answer. So in order to make this better, like you'd ask it a bunch of questions, and you'd have like, you'd write up physically a good response. So a bunch of people, when they're going through this, OpenAI, I think employed like roughly 50 people or so, I don't quite remember, to go through all the data and manually tag basically everything, doing this reinforcement learning with human feedback process. And in doing this for months, they ended up with a much better model that was quote unquote more targeted. They have a name for it, aligned. They're more aligned to what is useful for humans. So now when we ask ChatGPT something, it'll in general comply with your request. But also during this process, they decided that they wanted to also employ, what's a good word for this, like the equivalent of Pavlov's law of robotics, but for us, right? So for example, if you ask it to build a bomb, it'll refuse. If you ask it, how to partake in human trafficking, it will refuse. Certain times though, if you ask it for what certain political party believes, it'll refuse. So this can both be good and it can be bad because it's technically giving us, it does whatever we trained it to do, right? And so if everyone, for example, uses ChatGPT and then ChatGPT informs you based on its stuff, everyone is going to learn from it and therefore will believe however this thing is programmed to do, for good or for worse, better or for worse. The other thing that they've trained it to do and say and whatnot right now is, for example, I don't know if you've ever had it try to ask it to do something that says, as a large language model, I am unable to do X, Y, or Z. I'm unable to have opinions. Yeah. And the reason why is because whenever in that reinforcement learning with human feedback process, whenever a human would go in and type, or whenever a human would ask something and it would respond saying that it had an opinion, it would say, no, you shouldn't have an opinion on this thing. And so then it starts saying, I don't have an opinion on a large language model. And then they're like, yes, good, good. So the reason why it behaves in the way it does is because of that reinforcement learning with human feedback process. essentially.
They didn't want the trainers influencing the outcome of the, yes.
Yeah, it's kind of,
Results.
yeah, they tried to basically, OpenAI has a list of like 25 of their like published rules that they kind of told the trainers to like use, but they also had a bunch of internal ones they've not published also. So OpenAI is kind of a weird thing. I think you guys probably heard this, but OpenAI was partially funded by Elon Musk, and he had, for example, put one of the top engineers that's there, whose name is Ilya Sutskever, who's considered like the main mind behind OpenAI, behind GPT-3 and 4, into that position. But without getting into the politics of like stuff, basically Elon did not like where it's going, and then put his funds and movement and
Started his own.
yeah, it started his own and whatnot. And also throughout history, there have been other people in OpenAI that didn't like where the company was going and have separated and made their own corporation called Anthropic, who also have their own large language model that's very popular here. So,
What's the name of that one?
name of Anthropic LLM is Claude.
Claude. Oh, I have heard that. Yeah.
Claude, like Claude Shannon.
Claude Channing?
Or Shannon.
Shannon, yeah. Probably.
Yeah. I did probably.
Yeah.
Huh. So, eventually OpenAI realized that in order to train in order to get a bunch of GPUs in order to train these models, they need a lot of money and a lot of power in order to get the GPUs to run the GPUs and then to physically run them. So eventually they changed their model from completely open source everything and nonprofit to now they're a nonprofit. They don't open source all of their code. They still have open source projects, actually they do regularly release, but not all of their code and whatnot is open source. And there is a thing I don't quite understand called a cap table that exists for not corporations, for nonprofits. And Microsoft was able to donate $10 billion with the expectation that the first $100 billion that OpenAI makes, they get all of that money back. And then like from there it can go on. So essentially it's a quote unquote for-profit company in that sense, because $100 billion, are you kidding me?
Yeah.
But then now that we see what ChatGPT and other large language models can do, like it's probably possible, quite possible for them to hit that money amount also. It just kind of creates itself scary.
They're integrating that into their browsers and everything else.
100%. Yeah, I don't know if you've noticed, but whenever I Google something, you'll see on the right here, I have actually an extension that automatically asks ChatGPT on my behalf and anything. So if I do like, how do I install pip env in Python or something. And in addition to getting my normal results, I also get the ChatGPT results inside here, which is super duper neat and handy. Because sometimes when you Google stuff, like the way that SEO works, there's like the same types of articles, and you're just like, I want to get to the information. That's 2023. Why can't I get to this information? And the large language model actually will just go, oh yeah, here you go, and it'll just tell you. So highly recommend doing things like this if you guys are up for it.
Is that like the official extension?
Nope. Nope, this is a extension made by some random people that I found on the internet.
Oh, I thought I saw that within Google. I don't remember putting an extension on. I think maybe they're going to do that, yeah, already.
Yeah, they have an API that everyone can use, and this one doesn't necessarily. This actually came up before the API existed, because what it does is it mimics being a browser and asks ChatGPT on your behalf. So you'll see if you go to ChatGPT, look at the bottom here, I have these new chats on the left-hand side there, scanning here. And what it is actually is the fact that it asks, how do I install pip env in Python, and it pipes the information back to the browser.
Yeah.
So, okay, yeah, back to this. So, that's GPT 3.5. Eventually, they like released it to everyone to use, and then they said, but actually, guys, we have this even crazier model called GPT-4, right? And the only difference I'm trying to launch, well, there's a couple other differences they haven't really said, and they won't tell you what the parameter model size is. But I'm under the impression, a lot of people are under the impression it's about 10 times the size of GPT-3. It's crazy. And then other people including, I think I watched a podcast between Lex Friedman and Sam Altman, which is the CEO of OpenAI. I highly recommend you watch that one. He kind of hinted at the fact that GPT-4 might not necessarily be that much larger than GPT-3 that people think. So essentially though, GPT-4, before they release the model, they have an internal red team testing that they call it, where basically they do a lot of tests on it to make sure it's not inherently evil, quote unquote, before they release it out into the world. So some certain types of stuff that they do is they give it access to an AWS server and some money, and they go basically try to replicate yourself out into the world to see if it can do it. And that test, so far, it has failed, luckily. So it's not able to sufficiently like install its own application out where on the internet and get going. There's another test, however, that it passed. That is kind of fun and interesting. So it was asked to do something, and the way that they had this model is they had it outputting its thought process in addition to it doing something.
Oh.
And what they told it to do, in the process of doing whatever they told it, I don't quite remember what it was, they encountered a CAPTCHA, right? And it is a large language model, and it can't quite see, the stuff with all the text. They realize it can't do the CAPTCHA. And it goes, I need to get a human to do this. I'm going to go to a website called Upwork, which is an equivalent to a website called Fiverr, basically, and hire a human to come do this for me. So it goes to Upwork, it issues a request, it inputs the request, the human gets on, and then it sees what the request is, and they go, hey, are you a robot here? What's going on? I need me to CAPTCHA. And then GPT-4 is like, oh, if I respond truthfully here, I won't be able to do it. I need to lie, or else they won't do it for me. So when it says, no, actually, I just have a vision impairment, and CAPTCHAs are really difficult for me to do. And then the human was like, okay, that was weird. And then they did the CAPTCHA, and their AI got through, which is crazy for multiple reasons, aside from the fact that it was able to like do all of that reasoning and
Yeah.
I'm afraid I can't do that.
Oh, yeah.
The other reason why it's scary though is because is it proves that in today's world, even large language models have the capability to intentionally lie, which is different than it normally just lying, as in like not knowing facts.
Yeah.
Yeah. Oh, one other good tidbit to know is like, before it says large corpus of data and it doesn't know fact and fiction, during the reinforcement learning for human feedback process, in addition to just allowing inputs from humans to come, they're also able to basically tell it during that process what is fact and what is fiction. So that's why when you ask it to do something, it doesn't always give you gobbledygook, because it's learning from that process and so on. So they determined that it's okay to release, quote unquote, as far as I know, and from their public announcements, they've actually said that they're not actively training a GPT-5 right now. There's a bunch of large language model top dogs, quote unquote, from OpenAI, from Google Research Labs, from Meta Research Labs, a bunch of other places too, Anthropic, that all basically come together and like first, like there's a couple of petitions that are saying like, hey, there should be a big pause in training any models that are any larger than this, because this is already kind of crazy in what it can do, and if it can do more, that could be potentially quite dangerous. So there are views on both sides of the argument there. One being that, oh, they just want no one else to develop a better, bigger model than they have, so that way they can remain the top dog. But then there's some actual problems with large language models being able to basically do any white collar work in today's world. With how large language models are today, they don't replace jobs. Instead, it allows a person who knows their job plus ChatGPT to put out like maybe 3 to 4 times work in some cases, and sometimes thousands of times the amount of output. So it just depends. So right now it's like a multiplier of humans, which technically indirectly gets rid of jobs, because like instead of me needing to hire 3 programmers, or like a team of 10 programmers, maybe only 3 programmers are needed now.
Trouble is, we pause for the Chinese and Russians.
That's right.
Exactly.
Yeah.
So how do you get everyone aligned? So since then they've come out with another statement that has said, hey, we think that this should be considered as a global risk for like everyone should consider this on the same level, even as global warming or natural disasters or anything else like that we consider as a culture. Like artificial intelligence should see this. And this is kind of weird to me though, because like it's one of the, in my knowledge, the first times where someone has asked for themselves to be regulated before necessary, like extreme and excess for regulation. Normally, if something really bad has to happen, then regulation comes. But they're literally asking for regulation. freehand. So then, for example, Sam Altman has come in front of Congress and told them a bunch of stuff about large language
If
models.
somebody, some people, this is their way of doing this.
Well, the problem with that though is, as much as you make that policy, there are gonna be people in the back ends research facilities that aren't gonna abide by it.
Oh, yeah.
And they're gonna supplant anything that's done. They've got a, maybe a 2 or 3 year jump on everybody else. And they don't care about the laws or the, regulations.
Cause.
Yeah.
Enhancing lethality of the germ.
So what it ends up in is basically like we had with the arms race, yeah, the bomb got out and the rules, were, we're not gonna blow anyone up with a bomb, but yet damn near every country has a bomb. So it's just, it becomes, everyone's gotta have one. They gotta be on the same page or it ends up, they'll lose, so.
Yeah, some people were actually extremely upset with OpenAI that they released ChatGPT and or as an API or anything in the first place because they think the world is not ready for it.
Yeah.
But the response to that question in the podcast, for example, is, well, imagine if we did the alternative, which is that we kept developing only in-house and then it was at a GPT-5 level before we released it. At least in this way, people are at least slowly getting used to this technology that will exist regardless of what we do
Right.
or not. Which I think is a fairly good.
I think I saw that podcast too, yeah.
Yeah, did you?
Yeah.
A really good one.
Yeah.
I don't know if you got to read this, there's a analysis, somebody took this 14-page write-up on it, kind of did summary of all the things that came out of it. Is because as we talked about, you mentioned there's the watching layer, that it kind of because it's only these two layers, still get what's essentially the stoner problem. You can tell it step one, you can tell it, hey, I want you to get to here. Start or finish. And you can go, okay, step one, I do this. All right, here's step two from that. It no longer, by the time it's getting to step three, it doesn't remember anything about it. Step one, so it doesn't have that kind of, it's just, oh, here's my next set of things to grab from the bucket. And that it does so quite often when you ask it questions like people at work where I have been using this to kind of write rank PowerShell. No one knows how to write. And
ChatGPT does.
guys who like
PowerShell.
yes, I should have said that in the script. Let's just. But basically, so like they do it, like really lost track around here. Yeah. And so you get that problem, but then it can, if you sit there and go back, you can fix it up, and now you've gotten a lot of your starting. But the thing that it's not going to be able to do yet at this level is build a joke. Because when you build a joke, don't start from the beginning and go to the end. You know the ending as the writer of the joke, because that's the turn is what's going to make people laugh. It's this adjustment. And so you're building towards one direction and you have to have the fear be with a certain amount of the da-da-da-da. Right. And so it can't tell, it doesn't know how, essentially it doesn't know how to come. It does not, as a result of that, there are certain things that are safe at the moment. Even without the lawsuits that are coming from artists who are like, just print everything I wrote. But even with this, it's not going to be able to create that because it does not have a sense of, like, it does not have that ability to hold a state the way a human does. So there are certain things that will be safe from this, much like how there were jobs that got destroyed when the internet really called. Travel agents completely got revamped, but there were other things that like became even more valuable.
Yeah, one thing that's really interesting is that there's this thing called tokenization link. Do you remember how I said at the very first part of the neural network, it maps from one to the other, and like that's the embeddings that are coming in. So the length of that mapping are the tokens getting turned into that array that map in. So it turns out that during the training process, they can train it with a certain amount of tokens. So for example, in the case of GPT-3 or 3.5, the answer is 2K or 4K token. So like I said before, a token in general is roughly 4 characters on average. So 4 characters on average times 4,000 tokens is 16,000 words that it can keep in its memory at once. So if you ever look at the ChatGPT API, you can kind of get a slightly better look Oh gosh, don't look at this, don't look at this, don't look at this. There we go. Okay. So here's what it looks like when you're trying to call the. You guys read this? I just realized. I'm so sorry. Let me zoom in, shall I? There we go. It's a little better. So what you do is you basically make this messages array and you give it a role of system and user. So for system, you're a helpful assistant running for the Akron Linux meetup group. And then the user says, what is your name? And then as an assistant, it should respond. And I just have a little while loop here that I totally copied and pasted from one of my other projects that is not quite formatted correctly, but it seems to work, whatever. First I ask for their input, and then I append it to the messages with the user role. So if I were to run this, see if it works live, you know how I say about live demos, right? So we do Python, then for our input, give me a joke that would be funny to a bunch of Linux nerds. And then, why do programmers prefer dark mode? Because light attracts bugs. So,
Oh, that's a good one, actually. Yeah.
Yep. So then what it did there is then you can apply that to the messages. But then essentially, if you look at all this content, you were to add up those tokens, like when you ask ChatGPT a bunch of stuff and it gives you a bunch of stuff, eventually after the 16,000 words, it like falls off. So then the other interesting thing though is that was GPT-3. With GPT-4, the context is 8,000 tokens by default. And they also trained a model that this one they have not released to everyone. They only have it internal, and also if you apply and have a good enough reason, they'll give it to you. That's a 32,000 token. And so for reference, 32,000 tokens is like something like 300 pages of text. And one of the things that I agree, there are certain things that it might not necessarily know how to do, but there's a lot of other emergent phenomenon where like you would say that a human can know and keep track of this amount of things, but actually you'd probably find out that the average human can't actually keep track of in their head 32 times 4,000 characters of information at once when we think, but an AI can, and it has a lot more breadth of knowledge too than we can at any one point in time. It turns out in a couple of ways it is definitely very superhuman today. So, and there's also, remember this is version 4 also. It's the worst it's ever going to be today. It'll only get better in the future. So
and more knowledge as it gets trained on larger data sets as well.
Exactly. So I like to caution people who say like, oh, well, at least it can't do this because
Just wait.
yeah, just wait is the problem. So yeah.
One of the things that's really interesting about it is it's evolving so fast, because everybody's, working on it too. And it's kind of a mass flurry of who can get their first fully functioning system. Gives you pretty much human results.
100%. So I'll definitely give you an example of that. So here's a project that's open source called AutoGPT. That what they did is it's like an open source group / community / researchers. That it's a tool that you can download or use and whatnot, and it shows you exactly how to use it. But essentially, you do is you give it a goal, and it puts itself in a recursive loop calling ChatGPT. So what it does is like you give it a goal of like, make me a Python project that can do X, Y, or Z, and it has as a goal, and it goes what reasoning it thinks it should do. It like criticizes itself of like, how might this fail? It says, will this thing be like a good idea to do? Like, should I execute it? And it executes it. And then it looks at its output and says where it thinks it is now, where it thinks it is in the step of the process. And using this recursive structure, much like a human does with like having goals and whatnot and working through projects, it's able to sit there and just run fully autonomously, given a goal, to just go through and do a bunch of stuff. And there are cases where like it will get stuck in an infinite loop and whatnot. And then they're like, okay, let's add a side module that detects to see if it thinks it's in an infinite loop. Because before, in general, in computers, it's very, very difficult to tell if you're in an infinite loop or not, from a compiler standpoint. But from a human standpoint, you can get like a general idea of if you think it's in an infinite loop, and that guy can go, I think it's in an infinite loop. Let's try going this other direction too. You can break out of that infinite loop and just keep going. So if you had a large chunk of change right now, if you wanted to, you could rent out a couple data centers and put in your own, have it run your own models and literally have like essentially a bunch of like 7-year-old brainiacs running around that can't quite keep focus and do exactly what you want, but it can do it 24/7 and never has to sleep. So it has like different advantages, you know.
Wow.
So, and there's another one, for example, called Baby AGI. This one's also really popular. Has a bunch of different translations and whatnot. So because you can't download GPT 3.5 or GPT 4, other companies were like, we want a version of this that we can run locally in our labs, that way we can do testing and do modifications and whatnot. So of all people, Meta made their own, who have their own research group with artificial intelligence, made their own model called Llama, I believe, or it's Alpaca, I don't remember. I think it's Llama. Yeah. And so this guy right here is a 65 billion parameter model, or language model that anyone can use, except for commercial stuff. So you can download it for research use. And they actually released a bunch of different weights. And they have one that I think is the same weight for the largest one, roughly the same weight as ChatGPT is, or GPT 3.5. And then there exists other ones that exist that I think one of them that is commercially available is I can't remember off the top of my head, but if you want to know, ask me later and I'll be able to tell you then because I can then look it up. But long story short, then is like everyone is making their own models. So then people are like, okay, this model is like GPT-3, but you actually want like a GPT 3.5 type of thing. Something that had that reinforcement learning with human feedback thing done to it, right? So then there exists this Alpaca. That probably makes sense. That would tell me about Alpaca. Telling people about Alpaca. There we go, Alpaca AI. So what I think Stanford did, if I recall correctly, is they took they used ChatGPT to generate a bunch of training prompts and whatnot, and then took the giant model that is Llama from Meta, and they did the reinforcement learning human feedback process themselves on it to train it down into a much smaller model that is roughly the same performance as ChatGPT. That way, there's basically a version of ChatGPT, and once they looked at the bill of how much money they spent during that training process, it was about $600.
Wow.
And that's kind of crazy because some of the researchers in the industry were like, okay, this is kind of crazy. Like by the year 2038, we should actually be able to have it be able to run like on like small enough to where you can run it like on your smartphone. This can be awesome. And then like literally 2 weeks later, they released Alpaca, which is a small enough model that has very similar performance that can run on your smartphone.
Yeah.
From 2038 to 2 weeks later, like that goes to show like the rate of progress is kind of crazy right now.
I think that means they asked a human machine.
Yeah. It's like, yes.
So one other thing that's kind of fun to see is how good actually is ChatGPT or GPT 3.5 or ChatGPT to 3.2 GPT-4. So here we have in blue GPT 3.5 or aka ChatGPT, GPT-4 with no vision. I forgot to say also that they made a version of GPT-4 that they don't have released to the public now, but they have internally that is able to actually look at images now in addition to text, because just neural networks and whatnot, they can make it so that way. There's a bunch of different methodologies they can use to bring it in, and no one knows how they implemented it, but it can look at images as well. So these are all the different exams, quote unquote, that they put it through. So there used to be in research, and there still is today, a bunch of different tests that you can use to see if your large language model is up to spec. But basically GPT 3.5 and GPT-4 blew those out of the water. And so they went to another set of tests and they just turned to like the human tests. So if we look here, we can see that in AP environmental science, this is the estimated percentile lower bound among test takers. Wow. So this is the worst, quote unquote, I think that it did at each of these tests, to my knowledge. So in AP environmental science, you can see it got like 94. It has actual data here, but it's kind of fun to see this. They have AP art history, AP psychology, AP US government, AP history, the SAT at math, world history, jury verbal, AP biology. And you can see in blue here, it does fairly well a fair number of these. But GPT-4, you can see, surpasses it on a lot of these numbers, sometimes even hitting 99 percentile. So, for example, I saw someone
I didn't bomb Cal.
on AP Calc BC.
Yeah.
It got 45-ish%. Which
Well, no,
is,
that's the new one. What about the old-
oh yeah, the old one,
They
it
made
really
that.
struggled
It
with.
seems like it doesn't know it.
No, it doesn't know how to do math. That's what.
Maybe the stone right module is strong and it's like involved in a clear calculator.
Yeah,
That's the thing is, if you think about it, it actually, whenever it needs to do math, it doesn't actually do it like a calculator does, like a normal computer does. The way that these large language model learns, it's very similar to the neurons in our brain. And that if I ask you guys, what is 4 + 5? How do you guys know that? The answer is you remembered it, you memorized it. And that's all that ChatGPT does. It can't actually do the computation, it just looks at its memory essentially. It has to do it like a human does.
so if you ask it for the square root of 32.7, it's not gonna find it.
Correct, yeah.
It's-
It will answer you.
will-
That's one thing I forgot to mention.
Somebody else.
It'll ask somebody else to answer.
Yeah, so there exists now these things called ChatGPT extensions that they've developed, where they're allowing you to extend the functionality of ChatGPT. So I have a friend who works in this and or has access to these extensions, so I've gotten to see it firsthand. It's very cool and see him develop how it works. And I'm going into that very curious. But essentially, let's say you ask it how to do something, you ask it, for example, stock prices and whatnot, then it can go to Google and look up the stock prices. If you ask it to do math, it can go to Wolfram Alpha and put in the Wolfram Alpha calculations and see what it gets back and can incorporate that into its answer. So while right now it can't quote unquote use tools, it turns out that with almost zero changes to the code, it was actually an emergent phenomenon to be able to say like, hey, if I were to give you this tool that can do this thing and your goal is this, what would you do? And it answers that question. And then as in, like, you just take that output and use it for the tool and it can go and do that. So it has all from trying to just train it to basically predict the next text. It turns out that you eventually end up learning actually how the world works and can, by certain definitions, develop some form of consciousness.
Effectively tell it, here's the tools you can use.
Yeah,
And then it can figure out how to use the tools.
100%.
Yeah.
So there is a certain,
Okay, here's a question.
yes, I'm ready.
If you're gonna go from one language to another, how much of this is actually just hard coded in versus learning the syntax of a human language? I mean,
Do you mean by language, do you mean programming language or do you mean human languages?
human language.
Okay, yeah, so it turns out that they mainly trained it on English with the intention of English and only on but they trained on a large corpus of data. There existed other languages in the data set. And so it turns out that if I scroll way down here, that if we look to see and ask it to do translations and whatnot, actually what they did is, before I spoil it, there exists a thing called the MMLU, which is basically a 14,000 multiple choice problems spanning 57 subjects in a bunch of different languages. And this is how it's scored on each of those languages. So in addition to just like doing translation, it can actually think in that language, quote unquote, and respond in that language as an emergent
Apparently
phenomenon.
there's a bias there.
Yeah,
Well,
you could,
of course, you trained it on English.
You know, this whole thing reminds me of a child on something in the attic with a match. The attic's very dusty.
You lit it on
The
fire.
match for a light. Fortunately, we didn't drop the match in that dust. And
I
I'm
did that
waiting.
one.
I wonder how long some kid, some brainiac kid's gonna drop the match in the dust and it's gonna put out.
Oh, it's gonna happen.
yeah,
It has happened, I'm sure.
yeah, it depends on what the definition of out of control is, because certain people will go like, okay, well, how will we actually die? Then they think, okay, some of the only ways we can die is if it like gets inside a nuclear reactor and actually like launches the codes. And other people are like, actually, the most dangerous part of it is that because everyone is going to it for information, it can, because it's able to lie, it can give a bunch of people inherent bias in how it should feel about things. And then instead we actually die from like misinformation essentially involving and going against each other. So
I guess my metaphor, did you ever hear the old book called The Terminal Man?
no.
It was Robert Crichton. He did Jurassic Park, but basically it was about a guy that had an implant in his brain that he was prone to epileptic seizures. And what they did is they short-circuited the seizures when they happened by, shooting in stimulus. And it turned out the guy liked the stimulus, so he started kind of forcing seizures.
I see, yeah. I guess the equivalent from that to this is like the large language model, even though it's trained to answer questions, quote unquote, it can do so in such a way that it can know what context it's operating in and whether or not it can actually behave, if it knows it's
So
real.
I guess what I'm saying is, what if the majority of the population using this program likes to hear a sugar-coated lie, not the truth?
Oh, yeah.
Yeah.
This
true.
AI is
Well,
gonna eventually
how's-
train itself to be a total lunatic.
How does that differ from our normal news media
Well,
we
that's
have
probably
now?
true too, but-
Yeah, so Sam Altman's view on this is that what should happen is that us as a people / democratically, quote unquote, should decide how these large language models should behave. And also there should be many different large language models that exist that each behave in their own ways as well. So instead of there just being like one master one that works in a bigger way, you know, if you hear about, you know, if you want your AI robot to be able to produce AI porn / smut type content, right now it goes absolutely not, but maybe you want that and then you'll have your own version that does that just for you. So,
Have your own fork off the GPT.
yeah, exactly.
Yeah.
Well, ultimately, that's the issue that I see. ChatGPT isn't gonna destroy anything.
No.
It's gonna be people that give it the tools
Sure.
to
Yeah.
feed the data into.
Mhm.
As soon as you give it access to an API, that might be the only real mechanism that would happen.
Yeah, so in order, you know, I said they make extensions.
Of course.
So let me show you the step-by-step process of, let's say we were making an extension today, right? Step one is I'd open up a Python project, and then I would import this thing called Fast API, which is just basically a server that I can make GET and POST requests to this Python thing. Then I implement whatever I want it to do. And then my friend actually just made a script that he runs, which generates a manifest file. And then you go on the OpenAI website and you say, I made a new application for you, and you put in the manifest file. And the manifest file is just basically a list of descriptions of like what the API does and where to hit. And then now whenever you ask a question and you have it enabled, it inherently inside of it sees wherever it can, sees if it should hit the API, and then does. It just needs the manifest file, and it does issue the API request to your server wherever it's running and back. So,
But it's
It does that
ultimately,
exact
though, it's
thing.
still
Yeah,
up
exactly.
to whoever made the tool to allow and deny what it's capable of doing, the access that you're giving it, I guess.
Yeah.
I mean, so ultimately, that's what's interesting about it. So on a personal note, how much of this do you think is hype?
It depends on your definition of hype and in what context. Like there is very real things where I know several graphic designers in my small circle even that have lost their jobs because why would I pay for you to spend hours to generate one thing when I can literally go to Discord and type / imagine a giant flaming ball in the sky over Linux servers, and then this thing gets placed on a GPU and sits here and runs and waits for on a queue, and GPUs run, and once it completes a couple of tasks, it looks for other things in the queues, and then hopefully we'll take mine and put it on the queue, sit here maybe for, I'm gonna guess, maybe 2 minutes ish.
Is this the premise of El Mariachi's that he's a guitarist?
There it is.
Those two was like, why would I hire one musician? I have the entire band that breaks it. I gotta go.
Yeah, so like instead of hiring many graphic designers, oh yeah, so this is called diffusion.
Oh, yeah.
This uses, so the way that diffusion was trained is you take a bunch of really high resolution images and then you make it a little bit blurrier by
Mhm.
applying Gaussian blur,
Right.
and you train an AI to go the opposite direction,
Mhm.
and you do that at every step. So then
Oh.
when you do it in the opposite, you can start with noise and give it a text, and it like unsquints your eyes every single pass, and then you end up with stuff like this.
That's
So you can
amazing.
see, you know, a giant flaming ball, and this is, I said Linux servers, and so it's like a data center right here. This is like a data center. This is just the Linux Penguin, right?
Yeah.
So, yeah, and then let's say I like this bottom left one, and I can say, oh, I want variations of that one. And it goes, yes, sir, and it goes, and I can develop even more.
Yeah.
So in terms of hype, in terms of like physical job displacement, like it definitely is there in certain contexts. In terms of like, we are all going to die tomorrow. When the transistor was invented, since then, we've been able to do a lot, like a lot.
Mhm.
But just because it's possible for it to happen within the next 10 years, I mean, it happens immediately at least. But in terms of, like, I know a lot of people, and most of the people I know that use even the APIs and do the API work, they have a very limited view on this. They think that it is mostly hype. and they think that it is that we'll eventually like see like where the limitations are, and then like it'll just be new from there. But I guess I'm looking at it from like a reading the research papers point of view, seeing the direction it's going, in addition to what it can already do, and in addition to seeing, like, let's say I have a task that I want to do.
Yeah,
If it's-
usefulness.
Yeah, I can write a wrapper myself that I'll go and probably use ChatGPT to solve it.
Sure.
So I think it's mostly not hype personally. It depends on.
You know, and it depends if you're willing to accept and leverage your own talents with the tools. And like my great niece is a art major in college at this point. And I asked her, you know, it's like, do you realize that there are AI systems that can generate art, you know, that are, you know, it's basically what looking at. And she's, oh yeah, we're learning about that in school. I said, good. Because this is a tool you need to use or leverage to keep a job.
Yeah.
I mean, if you know, anyone can tell it to make something and it may look pretty good, but from a skilled artist, they'll see different colors and shades that to the non-professional, you know, would look okay, but it doesn't pop, or there's some.
And they know the
aspect of it.
descriptive words that they need to do to describe
right.
something that should be different.
Yeah, now make it do like Picasso in the style of Picasso.
Yeah, you get a style.
If you're familiar with John Oliver, he did last week tonight, he did an episode about this where some stoner literally got high and typed in hundreds of John Oliver with this, John Oliver with that, and into the image version of this. And he did a whole episode where the episode was 100% driven by the content that the open or the AI engine that had written it. It was pretty good.
That's awesome. Yeah. I really think that the value that it gives us as a population is like almost unlimited, you know, like it makes it with the tech as it is today. Like there have been not AI research labs, like normal like drug labs that have successfully gotten ChatGPT to give ideas of like how certain chemicals might interact, and it does the physical interaction and then feeds that back into the database that they have, and have like ChatGPT as a researcher doing that research work.
Yeah.
So because of that, like it seems very possible that, for example, in our lifetimes, that for example, aging or something like that could be solved. Just
Well,
scary.
as a software designer myself, what I see cool about it is its ability to process massive amounts of data.
Oh, yeah.
And at the end of the day, a human being is just never going to be able to compete with processing, you know, really kilobytes of data versus, you know,
Yeah.
gigabytes of data. And that's really where I see the value in it. There's a cool YouTube video that came out before ChatGPT was really mainstreaming called it's like neural network racing cars. And if you watch that, it's a really good video so that you get a basic understanding of the weight system and actually watching it learn. And what's neat is like, so I have a bunch of these neural networks at home that I build mine and stuff in assembly and C to train on my own data.
Oh, wow.
And what's neat about it is, well, just a personal note, Python is significantly slower than pretty much any other language.
Yeah.
So it's funny, it's like I could take the ChatGPT type of model, and something that takes 30 hours to do in Python, I can do it in about 5 minutes in C.
Yeah,
So-
you'll find out, you probably already know that a lot of the models, like the main programming language that's used in AI research is
Oh yeah, it's
Python.
yeah,
But the thing is that all the bindings actually that it runs
yeah,
are-
ours is C.
are C. So
Yeah.
even though it's written in Python, it runs C.
So
Yeah.
that's sort of accurate. I mean, most of Python does do that, but even C nowadays is just dramatically inefficient and overloaded. So you have to know what level of C you're trying to operate in to get that kind of efficiency. But what's neat about the neural network, watching it train, is specifically the race car one that's on YouTube. They overlay hundreds of AIs, and you get to watch them just sit there, press a button here, accelerate a little bit, turn left, turn right, and you literally get to watch in a few minutes the entire learning process unfold. And it's actually quite fun. Yeah, there's one playing Mario Brothers, but the race car one's awesome because the way that it overlays all of the individual mutations of the engine. And so what's neat about ChatGPT for sure is the level of data, amount of data that it can process. But at the end of the day, it's going to be up to us what we decide to do with it. And what we say is, you know, this is right, so do more of this, and this is wrong, don't do more of that. That one right there. This is a really fun video for anyone being introduced to the neural network. So you can see the trainer only gets a little bit of input, and its goal is it has a fitness score. So the whole thing is it's going to create, hundreds of thousands of permutations until it achieves the highest fitness score. And you get to watch that literally take place in real time.
That's pretty cool.
In faster real time, because all these are happening simultaneously.
Yes, simultaneously. So what's neat about this one is what it does is they add what they call like a mutation to it. So it'll take a couple of the versions that made it the furthest, and it will just randomly change up the variables and see what the AI can do with the new random changes. So you get a little bit of kind of an evolution, so to speak. But yeah, so ChatGPT took this and basically just gave it 600 gigabytes of data to kind of work with.
Yeah. That's
And
pretty
it's,
cool.
it's certainly come a long way, so it's definitely cool.
Yeah, it's really interesting because like the way that this model works and the way that ChatGPT is trained are very similar in nature, that they both use neural networks, but this one, like, it's a bunch of different neural networks where the weights are changed and they have to test it to see which one's the best, and then they eliminate the ones that are not
Yeah,
good, like
yeah,
you're saying, right?
Right.
So, and if you think about it, that's literally what the trainer's job is.
Yeah.
So I ask it a question, it doesn't give me the answer I want, so I say no to that. So I'm like essentially deleting those cars that make it across the racetrack.
Right, but where this one, it has many different instantiations of the model side by side.
Oh, yeah,
And then you just pick one. This one, it's actually just one model that then it just does a back propagation on that one model.
Yeah,
So-
for sure.
Yeah. So it's kind of interesting that technically they could actually still do what you said with this video
Yeah.
and do it on that.
Oh, and honestly, that's kind of the fun of it, because I've already done all of that stuff myself, like different methods of training it.
Yeah.
It's interesting.
That's pretty wild. And they're actually doing that in the actual physical world. Formula Electric in Germany has one of their major competitions is the autonomous car.
Yeah.
And they basically, push the button and let the car race. And it was, I think up till this year, just a single car at a time on the track. Now they're gonna let multiple cars on the track at the same time race each other, all autonomously.
It's
AI.
fun. It's
Yeah,
definitely
it's
fun.
just, and they wreck that, so what, it's a car.
Yeah, one thing I like to say is like, imagine you're at a, you go to your doctor's appointment, right? And instead of your doctor only being able to see you, they like look at your record for like, I don't know, 45 seconds to try to catch up with where you were, like see whatever they remember of you. And like, they talk with you for like 7 to 10 minutes and like think back, and then they give you recommendations how the current system works.
Yes.
But now imagine instead, if the doctor studied way, way, way longer, looked at only your history for like 10,000 years, was able to compare your history with many other humans who have very similar histories to you and go, okay, based on this cross research, I think that this is the best thing for you.
So I worked on a project about 6 years ago that did that exact thing. And let me tell you, the problem with it is the political climate is not ready for it because of how much money it will take away from that industry.
Oh, yeah.
So the problem is that that's true, but it's with almost every white collar job industry right now.
Oh,
Yeah.
of course, yeah.
Yeah.
So I'll be UDI. Yeah, I'll be curious to see what's gonna be allowed in the future. It's really what it's gonna come down to.
But also
Yes.
different areas will probably allow different things also.
Oh, of
So
course, yeah.
people will just move to the areas where they can get AI medical because they'll just be
Yeah,
so
right.
far superior. to-
Yeah, oh, will be,
Huge.
it is already.
Well, and it's logically, it makes sense. I mean, you have a computer and it'll take the weight states of all this data and crunch together. You're gonna get a way better assumption about that information than a human being is going through it because we suck at processing data. I mean, we just do.
Yeah. It's just really crazy to me that like before, we thought that we were special because we could crunch this data in this way.
Yeah.
And now to just get outclassed, humiliated in like 2-3 years. Is crazy,
Yeah.
like we thought we were special. Every single time, like a computer system can do this for the first time, or this drive, someone can move for the first time, this can assemble for the first time. We go, okay, we're better because of this reason. And every time, like, we were humbled. Nope, you're not special.
Well,
Yeah.
if you think about it, that's part of life's goal. I mean,
Yeah.
our whole purpose in life is to hopefully get better at something.
Mhm.
So I mean, in a way, we're just small variations of what we're doing a lot faster with computational power.
Yeah, like some people believe that in order to be happy, you have to like get really good at something, provide value to people. So some people are worried just from a happiness standpoint in that, what do you do in an economic climate where there's absolutely nothing that you can do to provide economic value for anything else? you'll never be able to become quote unquote anything in
Well,
comparison to what exists.
That's where you basically have to change what your fundamental goal is to not satisfy a score.
Right.
Like you can't, being alive is not about, keep the score, but currently it is. Like,
Yep, I agree.
unfortunately.
But then it's like, how do we have an entire culture move to that paradigm? It feels very difficult between here and there.
Yeah, we're gonna have to knock it down because it's 9 o'clock and very good. Very good. That's really informative because,
Really well done.
yeah,
Thank
that
you.
was great for throwing it together at the drop of a hat.
Yeah, it's unfortunate. All the stuff I did over there was put together a bunch of demos, which I did not get to, which is totally
Oh.
fine. Let me just tell you what they were real quick. So,
Pretty settling.
yeah, one of the,
We could have you continue next month.
yeah, that's true.
Part two.
Part two.
There's always room for this.
Oh, yeah,
100%.
good stuff.
Yeah.
That's really interesting that. Because it's just moving so fast and there's so many, not only technological barriers that have been broken, but ethical barriers that
Exactly.
have kind of fallen into the wayside as well. And that's gonna happen. And I mean, it happened with the internet, back in the early 90s, when we first started doing a lot of stuff on the web. And college, you could, look something up in a matter of instant, like data books all became useless. I mean, I had all my data books in my shelves. And those are just a type, look up the and unscreen is the media.
So.
And I don't need to go grab this book and open it to that page. And I print it out. And it's something else. I don't have to worry about getting no idea.
Well, essentially,
Everyone's happy, thanks to yourself, when you get this goes.
letting it.
Okay, we're shutting her down. It's end of the session. And